Stuff on the belt. So we'll go ahead and get started. I've been asked to read a few things to you. It says, please stay around for the drink celebration right after the 5 o'clock session and enjoy free drinks in the dining room down on M2. You will also be able to pick up a Redgate goodie bag that contains a t-shirt and a SQL Server book to take home with you. Please complete an event feedback form before the end of the day and pop it into one of the fish bowls or hand it to a Redgator for a chance to win an awesome prize, which is a conference ticket to the SQL Server Live or a SQL Tool Belt. The drawing will occur at 5:15 p.m. It says if you can't find a feedback form, don't worry, they'll be on the seats during the last session of the day, so you'll be able to complete one then. All right, you're currently in the Proactive Data Growth Management, Reducing Your Storage Footprint session. If you intended to be in a different session, please get up and run now. My name is Tim Radney. I'm the lead database administrator for a top 40 U.S. bank known as Synovus Bank, and I'm also a linchpin teammate. I get to work with folks like Brian Moran, Edie Leonard, Mike Walsh, Robert Pearl, several of my mentors and SQL celebrities that I looked up to 2-3 years ago, now I get to work with, which is really kind of cool. So, data is abundant. In 2010, it is estimated that 1.2 zettabytes, a zettabyte is 1 trillion gigabytes of data were created. In 2011, an additional estimated 1.8 zettabytes of data were also created. And by 2020, it is estimated that data will grow by another 50 times. Folks, that's only 8 years from now. So where is all this new data coming from? Business growth. We like to hope so anyway. Working in the financial sector, that has been the case for me. More data warehouses and BI needs. In these economic struggles that we've had over the past 4 or 5 years, more and more companies have started having to analyze and dig into their current data set. They're looking at profit margin, where they're spending money, where they're losing money. So as that need continues to grow, so does our data. The reporting needs are on the rise. We're having to keep data longer and keeping it online. We used to be able to archive things to tape, you put those offsite somewhere. Now companies need to be accessing that data real time, so we're having to keep it online on disk. Regulatory requirements. Again, I stated I work for a bank, we get scrutinized. The requirements that have come out for us are astounding. It used to be you could keep data 5 years, 7 years, now we're having to keep it 10. mortgage loans. Anyone have a 30-year mortgage? We have to keep that data for 30 years, for the life of the loan, plus 7 years. So if you wait to pay that loan off for the full 30 years, I've got to keep your data archived online for 37 years. That's a long time. Used to be that was in a paper file, in a vault somewhere, or in a storage bin. Now it's online, on disk. Backups and mirrors. All of us are becoming more and more conscious of our data and uptime, building out disaster recovery centers, high availability solutions. All of this takes more storage space. So what's the problem? Disk is cheap, right? Contrary to the myth, disk is not cheap. Enterprise storage costs range between $5,000 to $10,000 per usable terabyte. Does that sound right? I mean, we can go to Best Buy and get a terabyte hard drive for $50. So why does that in an enterprise storage solution cost anywhere from $5,000 to $10,000? Well, you have additional hardware and software maintenance, your installation costs, your host bus adapters, your switches, controllers, your cables, your cabinets, the racks. You have to cool it. You have to have the physical space to put it, the electricity to run it, the staff to manage it. I mean, this list goes on and on. You go to Walmart or Radio Shack, Best Buy, you buy a patch cable, that little piece of copper that you can hook from your router to your computer. You know, that cable's like $10. Imagine a 30-foot fiber optic cable. Most of your SANs are fiber attached. Those cables are expensive, I mean, hundreds and hundreds of dollars. And you don't just have a single path, you have two. So these things are really, really do add up. And it's not just the cost of that disk. Even though that cost is getting less and less, everything else is going up. That little HBA that plugs into your server that the fiber plugs into, those things can cost $2,000 themselves. So storage cost per gigabyte, although it is decreasing, it's only a factor of the cost of our SANs, our direct attached storage, or network attached storage. Even with all of that, our organizations, their method for dealing with this continual growth is we just add more disk. So we as DBAs, how many of us are database administrators that are responsible for these systems, maintaining the uptime, the backups, recoveries, and so forth? Okay. The rest of you, I assume, are database developers or programmers of some sort. Or you don't have to worry about the backups, that's my problem. You just get to work in the data. So we as DBAs, what can we do to help our organizations? We can utilize database compression on our duplicate databases. We can also use compression on our backups. Compression is much cheaper than additional hardware, and it provides several benefits. The main one is we're using less space. So where do we start? We want to utilize compression. What systems do we start with? Well, duplicated data, the easiest are your backups. And we know that's 100% copy of our production data. Our mirrors. Anybody using database mirror? Replication, our dev, QA, staging, training, test environments. Everybody has an extra copy of their data somewhere, right? Okay. We don't just develop in production. We should be QA in production. Reporting service. This is my favorite. There's very few cases that your reporting server has to have the same SLA as your production database. Now, if your transactions are coming into your OLTP system and your bond traders and everyone are accessing that data on a reporting server, well, yeah, okay, maybe. But most of my systems and reporting database are just for the bean counters or some of the executives to be able to go and pull numbers, and I don't want them mucking with my production stuff, so I move them offload them to another server. That environment, absolutely, compress that database. We have archive servers. I mean, all of these environments, we can go after and start looking to compress that data. In one of my production environments, my QA server, your QA should be almost apples to apples to your production environment. That's where you're going to do your QA, you're going to do your stress test, your load test, your functionality testing. So I like for those to be comparison, especially if I'm running a load test. Well, my site administrators bark at me and say, well, we're not going to give you this tier 1 fast storage that costs $10,000 a terabyte. We're going to give you tier 3, the same stuff I use for backups or development. And I'm arguing that that's not right, because if in QA something is taking a minute, and you're going to say, oh, it should run better in production. No, we don't know that. I don't know if it's a disk problem, or if it's some CPU, or if it's something in the query. So I argue that I need tier 1 storage. I'm now able to go back and tell them, well, that terabyte of storage that I need, uncompressed, I only need about 200 gigabytes with it being compressed. And their response is, oh, okay, yeah, no problem, I can give you 200 gigabytes, but I won't give you the full terabyte. So I'm able to manage and get better, faster disk and maintain my SLA by using it, by compressing that data. So what can Redgate do to help us with this? SQL Storage Compress. SQL Storage Compress compresses your live databases, saving 73% on average. Guys, that's on average. That's not a max. SQL Storage Compressed databases behave just like any other SQL Server database. And SQL Storage Compress operates in the background in the operating system. SQL Server is not even aware that this data, or that your data is compressed. So who wants to see this live and in action? Flip over to a demo. I'm going to start and show you that in all programs with Redgate, all I have installed is SQL Prompt. No SQL Storage Compress, no other Redgate tools. What I want to start with is the actual installation process. So when you go out to redgate.com/SQL Storage Compress and download the eval, you get a 14-day trial. And you download the zip file, you uncompress it, you'll have step 1, step 2, and then installation instructions. If you open the notepad, it will tell you, go into step 1, install, go into step 2, and install. So we can follow those instructions. I'm running on a 64-bit platform, so I'll run that installed. Now this is fairly quick in the sense of we're not installing a new version of Internet Explorer, but it does take a couple of minutes. And ignore the time, because this is Microsoft's assessment, this is a long second. So while this installs, I'll tell you a little bit about it. So the demo is for 14 days, like most Redgate products. If you need more time, you can go into the registration code and type, I need more time. And you get an extra 14 days. So this actually installs relatively quick. So that was step 1. We'll back up and go into step 2. We're now installing the graphical user interface. That first install was the Hyperback Engine. So I'd like to give an example. If you had a production database that was 1 terabyte in size, if you had that in dev, QA, and then a staging environment, that data is out there an additional 3 times. If you were able to get the average 73% compression rate, that 3 terabytes would be reduced down to 800 gigabytes. It's kind of impressive. Only if we could recoup and get that money back, right? And if any companies ever start these employee cost savings, you come up with the idea and you get 10% of what you save. Yeah, my company doesn't do that either. They want my ideas, but they don't. If I can save them $12 million, I get nothing. But well, you get to keep your job. Thanks. That is a good thing. All right, so SQL Storage Compress is now installed. So we'll come into Programs, Redgate, SQL Storage Compress. We will not participate in the feedback today, so I'll say no thanks. So it opens up. First, let me minimize and start up Zoom it, so you guys in the back may have a chance to see. So it installs. I have one user database, Encryption 2012. It's 2.529 gigabytes. That is not by default. If you go and download VentureWorks, think about regularly it's about 150 meg or so. I used a script by Adam Mechanic to blow this thing up to 2.5 gig. So to get started, all you have to do is click Restore a Backup. Let's go back and see that screen again. So Restore Backup to compress database. We'll click this. We'll click Browse. I've already got a database backed up out here. We'll say Next. It's going to validate, come up with a name. It will default to your SQL Server data files directory for the instance. What is really cool to note here is use encryption. So in my organization, there's a lot of databases that are in financial sectors that are PCI, regulated, SOX, things like that. A lot of folks work in the health industry, so you have to worry about HIPAA, things like that, where the database has to be encrypted. A lot of us rely on our storage to have that encrypted at rest. That's usually your high-end storage. That's one of those other reasons why it costs $10,000 a terabyte. Your cheaper tier 3 SATA storage is just a JBOD. It's just a bunch of disks for you that they carve up and give to you, where it's not encrypted. Here, if you're having to build out a development server on the lower end disk and you're concerned about having that data encrypted and you don't want to have to deal with TE encryption and go figure all that stuff out, it's just a checkbox. How nice is that to just be able to check a box? This database, when it gets restored, then it will encrypt. We're not going to encrypt today, so we'll hit click Next. And here you go. If I click Finish, it's going to restore this database and compress it. Or I can choose to use the script. I'm going to click Cancel, because there's a couple other things I want to show you. So I want to start out, because I'm also going to demonstrate backup compression. I'm going to back up this database, and we're going to be able to look at it and see how large it is just with a regular SQL Server backup. Now, while that's backing up, I want to show you the restore script that SQL Storage Compress uses. It's really no different. Restore database, your database name, and from disk. That's the backup that we're currently making. I specify with move. And I want to show you where the magic happens. What's unique here?
X at the end.
We're adding an X. So that first step in the SQL Storage Compress installer was installing the Hyperback Engine. By restoring your database with the X on the end, tells the Hyperback to compress the data file, and in this case, the log file. It's that simple. So we are complete with our full backup. Nope. Almost. 68%. So let this guy complete. So one could argue, you compress the data file and the log file, transaction log, that thing is really kind of hit a little bit more than your data file. That's all up to you. SQL Storage Compress, you can compress one or the other or both together.
If you're using SQL Backup, do you just specify those, the X at the end, and it will know the same thing when you're restoring?
So basically this restore is the native SQL command to restore database, right?
Correct.
And you're saying that by just running this and specifying X at the end, it knows so Hyperback Engine is running in the end, in the background, and it's basically taking control of that restore command?
Correct. Well, it's taking, when you're doing the restore, Hyperback sees that and knows that you want this to be a compressed file.
Okay.
So it's going to compress it on the back end. SQL Server itself has no idea what's going on. The Hyperback is at the OS level.
Right.
So SQL Server is doing its I/O operations. Hyperback's in the background compressing the data.
So in that case, if it was this backup was actually a Redgate backup, using SQL Backup, we run the same command?
Yep, you change the file extension to MDFX and LDFX.
Okay.
So it's, whether it's a SQL Backup or SQL Backup Pro backup, Hyperback doesn't care. Yes, sir.
2 questions. One, does it make sense to compress temp DB? Okay, I didn't think so. And secondly, have y'all benchmarked with SQL table compression, either row or page?
Well, there's with SQL Server row and page compression, one of the major benefits with that is that the data is read into the buffer pool, it's still compressed.
Correct.
With this, as SQL Server reads, that compressed page, it's uncompressed as it's coming into SQL because this is outside of the storage engine.
So to re-ask my question, have you done any benchmarking where you've had that also, so that it stays compressed all the way to the L2 cache?
I personally haven't done any benchmarking. The SQL Storage Compress Redgaters, I'm sure they've done some case studies there. My experience with it has been simply to reduce my storage footprint.
Okay.
So the experience that I've had with SQL Server table compression is if I have a database with a whole bunch of tables that are all roughly equally the same size, I'm having to go to each table and compress table at a time, versus what you're about to witness when we run this restore is I run one command and the whole database is going to be compressed. But that huge added benefit of if I've got 100 gig of RAM, the 100 gig database, and I'm able to compress that 100 gig database using SQL Server table compression to get it down to 50 gig, I can load the whole thing in memory. You don't get that with this, but in a later slide, I'm going to show you a 1.5 terabyte size database that I was able to compress to 500 gig and save a terabyte of storage. That's kind of sweet.
Right.
So what are you utilizing the compression for? And with this, it doesn't matter if it's SQL 2000 or 2012, you can compress it.
So you have to always come from a restore point in order to convert one database into a compressed database.
Correct. Yes. The way that you get the data compressed using SQL Storage Compress is through the restore. So that was relatively quick, 46 seconds. We'll launch SQL Storage Compress again. We'll go in and we'll be able to see it in the GUI. Both the databases. Let's see if I can resize this window. So we have our 2 databases listed. You can see that one is blue, showing that it's the compressed database. Both of them are the same original size. The compressed size is 1.05 gig. So a savings of 1.474 gig or 58%. It's pretty nice.
Let's say that your server blows up and you have to set up a brand new server. And then you have to install that, the middle, that, the Hyperback. And you have to have the same version, otherwise if you want to restore something that you don't have that version of that tool.
Well, see, you would be restoring your backups. So the backup, again, doesn't care that it was compressed. When you back up the database, it's just a SQL Server operation. If you choose with compression, you'll have a compressed backup. If you don't choose with compression, you will not have a compressed backup. So this is just the data file and log file being compressed at the storage layer.
You know how you can detach, copy the files into another test server, reattach?
That I have not tried with SQL Storage Compress. That's a good question. You're using the detach. At this point, I would say use a backup and restore, but that's something we can definitely ask a Redgater. Or send me after and I'll fire up another 2012 and we'll try that.
Does the Hyperback run as a service?
It is running as a service.
And do you know if it operates against other RDBMSs or just all SQL Server?
Good question. this SQL Storage Compress. But they may have there may be a version for Oracle or Sybase or something else. Yes, sir.
So once you've done this and you're writing new data, yeah, I guess that's compressed on the fly.
Correct. Yeah. So from here on out, the database is compressed. Any reads, writes, the Hyperback Engine is compressing or decompressing that data. So as you read, it's got to uncompress it for the storage engine, and as the storage engine writes, that data is being compressed as it writes to disk.
You know what kind of performance hit that
Yes, marginal CPU. I mean, the case studies that I've done at work, I've seen maybe up to a 5% increase in CPU, but most of my servers run between 15 to 20%. So for them to spike up to 25%, I'm not too concerned. It's really no different than regular SQL Server compression or backup compression. They all require extra CPU cycles.
about I/O?
I/O's been about the same. I mean, it's still reading the same the same data from disk and writing the same data to disk. I haven't noticed any extended waits or anything else that would cause me to concern.
Okay.
Any other questions? Yes, sir.
Okay, so my understanding is, if I have a 750 gig database and I want to compress it using this method, I have to restore that?
Correct.
So there's no on-fly type of restore?
Yeah, there's no on-the-fly press a button and tell it to compress this database. How you get it in to SQL Storage Compress is through the restore process. So you would have to have that downtime to do your backup and restore it.
Same thing to undo, right? You back it up and then you restore with the regular MDF, LDF, and
Correct.
you're back to without compression.
Yes, sir. So we'll take a look now. So with our backup, we'll see that the SQL Server native backup, and it was 2.29 gig. So one of the neat things to look at from here, if we use our SQL Storage Compress database, and we know that its compressed size is just over 1 gigabyte. If we tell SQL Server, go tell me how big this database is, he still thinks he's dealing with a database over almost 2.5 gig in size. Again, SQL Server is completely unaware that this data is compressed on the back end.
So if you went out and looked at the actual now MDFX and LDFX files,
Let's
they
do it.
would look like they're full size, not the compressed. I mean, because the space on disk is obviously smaller, right?
Let's see. So you can see that the compressed SQL Storage Compress, it's a little checkered flag on it. So if we scroll out, you'll see that the Hyperback archive is 1.16 versus 2.6. So in a real world example, I haven't been able to figure out how to zoom this in on PowerPoint. But this is one of my production servers at work. A 1.5 terabyte database compressed to 418, and I'm rounding out. You can do the math by 1,024 bytes if you want to figure out that's really 396 or something, but for our purposes, 155 down to 41. So savings of over a terabyte. And I did get that, 73%, and they're on average. That was total between these databases. So this one here was 950 gig, it compressed down to 212 with a 738 gigabyte reduction, or 78%. And this one was a half a terabyte, you reduced to 155 saving 361 gig in space, by 70%. My favorite, this is a true OLTP application, taking remote deposits, 35 gig in size, reduced to 4 gig. So you got 88%. Those are real databases pulled from production and restored on this dev server. Incredible.
So when you subsequently go into backup now to compress the database, do you also realize the significant time reduction in the take to back these up?
No, because this data is compressed, and the SQL Storage Engine does not know it's compressed. As it's reading that data to write it out to a backup file, it's uncompressing. So if I still have to choose with compression or use SQL Backup Pro if I want to compress the backup. This is just strictly at the storage engine compressing the data file.
You're not really saving anything in terms of backup time. I mean, I would imagine your 1.5 terabyte database takes a long time to back up.
Now, if I want to utilize SQL compression, or excuse me, backup compression, then yes, I see a significant decrease in the amount of time it takes to back up. But from this aspect, if I were to just do backup big database to disk, he's still going to back up 1.5 terabytes, or in the case of the second one, 950 gig. I still have to choose with compression or use something like SQL Backup Pro, which leads me right into how can I get help with backups. So how many folks are running a version of SQL Server of 2008 Standard Edition or less? Do you back up or do you compress those backups?
Yes.
What third-party tool? SQL Backup Pro.
Yours.
So with 2008 Enterprise and 2008 R2 and above, you have native SQL Server backup compression that's built in, which is quite nice, having that. It's better than nothing. And SQL Backup Pro can still get you even better. I mean, up to 95% compression, their average is 80%. You have multiple levels of compression with SQL Backup. For the longest time, I had been using the product for about 3 years and had no idea. The DBAs before me was just out of the box. They went into the app, they scripted out, they got that syntax, and we just used and reused that over and over again. It was using the out-of-the-box compression rate of 1. So I'll demonstrate in a coming slide those different levels of compression. But the coolest thing to me is the encryption. How many folks are encrypting their backup files? All right, so you 5 are the ones that I would have the hardest time hacking. So when you back up your databases, you're just backing them up to either network share or you're backing them up to local disk, correct? I mean, that's what we all do. Any SAN administrator, network administrator, system admin that has domain admin rights in your environment can go out there and grab one of these backup files. Now today, they probably, if you're on 2008 or above, local admins aren't inherently a system admin anymore. Thank you for that. So they can't go and query your database unless you've given them access, but they can go grab your backup file, download Developer Edition, install it somewhere, restore this, and now they're an SA on the box and they have access to all that data. So how do we as DBAs protect our organization, our jobs, the livelihood of our company to prevent that from happening? That's to encrypt your backup file. So if there's ever been a case to justify, hey, we need a product like this, the encryption aspect alone is worth the price. Then you get the compression as a bonus. One of the cool things about SQL Backup Pro, SQL 2000 and above. So all those nasties, 2000 boxes, 2005, you can still get some high rate of backup compression. It also has a centralized administration feature. By compressing your backups, you reduce your backup and restore times. You're using less I/O when you're backing up to using compression. Same with restoring. That 1.5 terabyte database that's able to be reduced to 300 gig, Now I'm only having to read 300 gig, I'm only having to write 300 gig. That takes a whole lot less time than 1.5 terabytes. It also, you can check a box to have backup verification, which is kind of nice. So those compression rates, using our AdventureWorks 2012 database, using the level 1 compression, we get 57.98%, level 2, 68%, level 3, 71%, and level 4, 81%. That gives you a difference of the backup compressed file being a gig down to 491 megabytes. What's the trade-off between level 1 and level 4? The time. So going from 1 to 4, you can pretty much expect it to double the time. If your backups are taking 8 hours, probably can't afford to use 16 hours to back them up. But if the level 2 or level 3 is time and a quarter, time and a half, you have to make that call. If your backups are only taking an hour, you can probably afford to use a whole lot less space. So you just got to figure out what's right for you. So who wants to see this demo?
Can I ask one question?
Absolutely.
If you encrypt the backup, how does it control the ability to restore by a login or what?
By a key that you specify when you back up.
You just created at that time?
Right. So one of the downsides of that is if you're backing up using an encryption key, you have to have that key to do the restore. You need to make sure your team has that. How many folks verify their backups through some automated routine? I do. So I have to have a script to do my restores. What's got to go in that script? The key. So now you got to get fancy of where you store that script and make sure that that's in an encrypted vault somewhere. There's very simplistic ways to protect that key. Number one, your sysadmins aren't going to know to go look for it. They're going to see a .SQL. They don't work in our space, so it's usually not a problem. But that's something to be concerned about. Is now you have this key in plain text stored in a file, so you can take a couple of measures to protect against that.
That's on the server, the SQL server?
But wherever you're doing your verifications, I have a dedicated server for verification restores. So we've just gone and removed domain admins from it, and that problem's kind of solved. So to get started with SQL Backup Pro, we need to install it. So we'll go back into the installation files. So when you go to redgate.com, SQL Backup Pro, and download the demo, uncompress it, you'll get a folder much like this, SQL Backup and SQL Multi-Script. It's included in the DBA bundle. So we'll launch this. I only want Backup Pro, so I'll choose it. Click Next. Agree to the licensing terms. Default version. And it's extremely quick. It does take a little bit of setup the first time that you launch it. We will not participate in the feedback study today. So you have to add a SQL server. I'm just going to add a local box, let it be my central administration server. I'll say connect. And then we have to run a server setup. So it's the SQB. So this installs the service. So right now it's checking, validating my credentials. And that was pretty painless. Now don't do like me and spend 20 minutes trying to diagnose why the thing's not going to work right this second. Because we just set it up, and like most programs, you have to close it and then go back in. Learn from me. All right, so our little dot here is our server. expand out. So we'll look at our AdventureWorks 2012 database. We'll tell it that we want to back it up. And this did this to me last time. Because of the resolution, I'm missing a dialog box. Quickly, I'll see if I can change the resolution. If not, we'll just have to move on. All right. So we'll say next. I want to do a full. I'll check the database. For your backup type, you can use this for full differential transaction log file group. Just like a SQL Server, you can do a copy only. Not sure why you would use the tool for that. Unless you, well, I guess if you still wanted to compress a very large database. So we're going to choose the AdventureWorks 2012. I'll click Next. Our options here are a single backup file. We can overwrite a file, copy it out to a network. We'll take our defaults and say Next. This is where the magic really happens. So we're going to choose compressed backup. Your compression level. Notice it defaults to 1. So folks that go and buy the product, and out of the box they go to do a compressed backup, they may not be as thrilled as they could be had they slid this little bar over. We're going to take the default. You can click on the Compression Analyzer, and it will tell you what these 4 levels would be like. That was the slide that you just saw. We'll click Next. We'll let it run the checkzones. So you get your summary of everything that's going to happen, but notice you have the script there. So if you wanted to throw this into an automated routine, you could take the script, copy, paste it, put it in a job, and just have it run. So because I like using the T-SQL, we want to see the comparison from SQL Server compression and Redgate, right? We want to see a side by side. See, now I need a resolution back larger. For this, y'all will have to ask some questions because this will take a minute or 2 per backup. We're going to start off with just backup database AdventureWorks to disk with stats equals 1 and compression. That's straight up T-SQL. There's no Redgate involved there. Last time I ran it, it took 1 minute and 21 seconds. So we'll see how long this one takes. While that runs, I'll show you the syntax for the Redgate SQL backup. So it's executing master, and then I guess their stored procedure SQL backup. It's a backup database name with 2 disks, specifies the location. Notice the extension, SQB. Anyone else pronounce that squid? That's what it's been called in my shop for 4 years, and I don't know if that's correct. It's kind of like, is it a GUID or a GUID? What do you, GUID, how do you pronounce